Okay guys, here we go. We're going to go to start the section off. So again, inequalities in one triangle. We're going to come out here and recognize and apply properties of inequalities to the measures of the angles of a triangle, and recognize and apply properties of inequalities to the relationships between the angles and sides of a triangle. So let me just move on up. So we're talking about the triangles, okay, and we're talking about how they kind of, have sides and so forth, and what kind of comparisons we can do where stuff is greater or less than, so forth. In algebra, you learned about the inequality relationship between two real numbers. The relationship is often used in proofs. So for any real numbers a and b, and you know that a is greater than b if and only if there is a positive number c, such as, look at this, a is equal to b plus c. Remember, we're saying that a was bigger than b, right? So when they're equal, if I can go ahead and add another number to this one to make it equal to this side over here. So we add b and we add some c to it to make it equal to b. And that makes sense. But if you look at this real quick, let me give you an example right here. So we have this 5 as your a, you can say. And when we have this b, we know that 5 is greater than b. We're going to add this other number c to it, which is now in this situation a 3. We add these together, now they're equal to that 5. But alone, we know that what? The 5 is greater than the 2, and 5 is greater than that 3. And we added these two small numbers up to give you that bigger number. And that was, basic. It's pretty easy. Okay, definition of inequalities. The table below lists some properties of inequalities that you studied in algebra. So we went through these real quick. They're pretty easy. They make sense if you think about it. So there's a comparison. So when you compare two things, you can have it where the first one, A, is smaller than B. You can have it where they're equal to each other, or you can have it where the A is bigger than the B. It's pretty easy, okay? Transitive property, remember, transitive, like the transportation that carries through. It means like it goes like from one to the next, and it carries on the same idea. Watch, look at this one. If A is less than B, okay, and you know that B right here is less than C, well then you know what, from the beginning, that A is less than C. Makes sense. It looks pretty cool. So we kind of studied this stuff before, so it's kind of revisiting. Now it also makes sense the other way. If you know that A is greater than B, and then that, well, in the situation B is greater than some other number C, well then you know what, that A is still greater than that C. Okay? Addition property of inequalities. So this is saying there's a relationship. You know that A is greater than B. And you get some number C and you add it to both sides, right, of the inequality, and it stays true. So if you had A, whatever number that is, and you had B, whatever number that is, if you come out here and add a same constant or same number to both sides, then the inequality still stays true. And we use that to solve the inequalities. That also happens when it's smaller. Subtraction property. This is the same idea, both of these. Okay, so if we have A is greater than B, but we have some C that we take away from A, and we take away that same C from the B, then this left-hand side is still greater than that right-hand side. So as long as we're consistent in adding the same C's or subtracting the same C's, then the inequality still holds true. Okay, so we said this stuff. We use it pretty cool back in the days. Don't take it for granted, but we're going to use that forever and ever now. The definition of inequality and the properties of inequalities can be applied to the measures of angles and segments, since these are real numbers. So remember, all the numbers that we taught, all the angles are real numbers, and angles are real numbers. Side lengths are real numbers too, so we can add them, divide them, subtract, so forth. That's what it's trying to say there. Consider angle 1, 2, and 3 in the figure below. What do you know about? Do y'all remember what you know about angle 1, 2, and 3? Does anybody remember what those things would happen? Okay, just in case you forget, this is called your exterior angle, and these are your remote interior angles. The remote interior angles add up to give you the same value or the same measure of the exterior angle. So by the exterior angle theorem, you know that the measurement angle 1, this outside exterior angle, is equal to the measurements of these two interior angles. Okay, so remember this. This one is equal to the sum of these two. So what does that mean in this situation? Well, then we automatically, you can say that this one's already greater than that one, and this one's greater than that one. So that's what this comes out here. Since the angle measures are positive numbers, we can also say that the measure of angle 1, this one outside the exterior angle, is going to be greater than that interior angle, and it's going to be greater than that interior angle. By the definition of inequality, this result suggests the following theorem. Okay, I think I'm talking too fast. What do y'all think? Do you have any questions? Are y'all awake or not? Mediums? Más o menos? Medium? Welcome back, Fabian. Brother. Okay, let's go on, right? Good morning. Okay, let's come over here. So here's the exterior angle inequality. Okay, so remember, this is your exterior angle. These are your interior angles. Remember, this one is equal to the sum of these two here. So by definition, by the other idea, we know that when we add these two up, these two smaller ones add up to that bigger one. So individually, you can say the measurement of angle 1 is greater than angle A. The measurement of angle 1 is greater than angle B. So the measure of the exterior angles of a triangle is greater than the measure of either of its corresponding remote interior angles. Okay, I'm going to take a break real quick, guys, and let y'all copy that down. Okay, let's go and move it on up. Okay, each exterior angle of a triangle has two remote interior angles that are not adjacent to the exterior angle. So make sure you know that. This one's adjacent to it, right next to it. This over here are not adjacent to it. These are your remote exterior angles to that. I'm sorry, remote interior angles to that exterior angle. Okay, so use the exterior angle inequality theorem to list all the angles that satisfy the stated condition. Okay, we want to go out here. Measures, okay, less than the measurement of angle 7. So let's find angle 7. Let me see where in the world is angle 7. Angle 7 over here. Okay, so that's like my exterior angle, and the remote interior angles would be 4 and 5. So what do we know about these two right here? Well, those are the ones that add up to give you that one, right? So we're going to come out here and say that. Angle 7 is an exterior angle to triangle KML, this one here, KML, with angle 4 and 5 being as its corresponding remote interior angles. By the exterior angle inequality theorem, we know that this one is greater than that one and that one. And that's what it says right there. Pretty cool. Going once, going twice. What do y'all think about that one? Okay, now we're going to come out here. So angle 7 out here, guys. It's that triangle right there. And let's read this one over here. This is a pretty cool idea. Angle 7 is also an exterior angle to triangle JKL. JKL. So angle 1 and angle JKL, you know, you see this right here, JKL, which happens to be these 2 and 4 together, are remote interior angles. So the measurement angle 7 is greater than angle 1, makes sense, and the measurement angle 7 is greater than the measurement of JKL, the other remote interior angle. Pretty cool, or what? Since we know JKL, we know this JKL, this angle right here, is equal to the sum of these two. And by substitution, we can say measurement of angle 7 is equal to what? The sum of these two? Well, we already know it's greater than that one, so we're going to come out here and also say that it's greater than that angle 2. Which is pretty cool, because now we know that this one, angle 7, is a remote exterior angle for these two, 4 and 5. So it means automatically angle 7 is greater than 4 and 5. And then we know, since it's a remote, or it's an exterior angle for this big triangle, has to be greater than angle 1, and it has to be greater than this 2 and 4 together. But we already stated that 4 was smaller, so we're going to just state that 2 is smaller. That makes sense. Pretty cool. Any questions over that one, guys? Yes, no, maybe so, más o menos. How do we feel? Not too bad? Okay. Okay, so let's come in here. We're going to find measures greater than angle 6. Where's angle 6? Well, if we look at angle 6 right here, what do we know about that one? Anybody know anything about that one? Okay, so right here, if you look at this one, angle 3 is an exterior angle to KLM. Let me move this up. So angle 3 is an exterior angle to KLM. So by the exterior angle inequality theorem, measurement of angle 3 is greater than measurement angle 6. Measurement angle 3 is greater than angle 6. Does that make sense? Because 8 is an exterior angle to JKL. Okay, 8 is an exterior angle to JKL. You see that one? And we know that, well, we know that measurement 8 is greater than, this one is the interior angle to 8 also. So now we know that that angle is greater than 6. So now we're going to say in the situation we have that angle 3 is greater than angle 6 and angle 8 is greater than angle 6. 6 happens to be a remote interior angle to that 3 and to that 8. Yeah, oops, gave you the answers. Where's the movies? Don't want to get that one. Okay, let's copy this down real quick and let's see what's going on here. Okay, let's go ahead and do this. You should have it copied down already. So let's look at this one real quick. When it's talking about comparing, right? Making or finding angles that are bigger or angles that are smaller. So let's come out here real quick. We want to go to find angles that measures less than angle 1. Angle 1's right here. So if you see that one real quick, I'm going to kind of draw it like this. This is your exterior angle. This is your interior angle. This is your interior angle. Okay, these two add up to give you that one, right? So all I got to do is talk about these right here, right? These two right here are going to, when they add them up, give you that one over there. So these two are basically smaller. Now, let's look at this corner over here. This corner, this situation right here, has a 3 and a 4. That whole angle is made up of 3 and 4. So I can automatically, in my opinion, I'm going to say angle 3 and angle 4. Since you add those two up, but together plus these other two over here are going to go ahead and add up to this exterior angle. Then individually they got to be smaller. It's just like a no-brainer. It's like what's it called, the transitive property? Because you know these are smaller than that one, and this one's smaller than that one, and this first one is originally smaller than the other one, I guess. So I'm going to say 3 and 4. So then right here, angle 1 is going to be this. Right here is a part that's interior. And then this other part over here are the other interior angles. So we'll go with angle 5 and angle 6. Cool. Remember, this one's bigger, and then these are smaller. You have any questions over that stuff? That was pretty good, pretty easy. Now I'm going to switch up the colors, and let's try this other one. The measure greater than angle 8. Where's angle 8? So I'm seeing that one real quick. So I'm going to draw this. See that? This is exterior angle, interior. This is your 8. That's that one right there. So you know these right here, okay, they're not equal. I'm just saying when you add them up, they add up to that one over there. Well, the thing was saying, if I know I have to add up two smaller things to give you that one right there, just to give you something bigger, then that one by default is automatically bigger. So I'm going to say that angle is angle 2. So angle 2 is greater than angle H. Well, once going twice, what do y'all think? Pretty easy? Kind of cheesy? Not too bad? So-so?